we need to take a look at graphing radical functions, specifically square roots and cube roots. We'll start with square roots. Now, all of our graphing this year is centered around transformations. Generic form of our square root function is y equals a times the square root of b, the quantity x minus h, plus k. Each of those variables holding the same transformational purpose that it has for every other function we've looked at, based on location within the equation. A controls vertical dilation, both stretching and compressing. Stretching when it's greater than 1, compressing when it's between 0 and 1. It also controls reflection. Reflection is any time that A value is negative. B holds the same kinds of powers, only it's in the horizontal direction. B controls horizontal dilation, stretching and compressing. When B is greater than 1, we compress. B between 0 and 1, we stretch. It also controls reflection. This time it's reflection in the y-axis though. Again, anytime B is less than 0. H is our horizontal translation variable. It controls movement left and right, sliding this function. And K, our vertical translation variable, controls sliding both up and down within the plane. If we're going to graph y equals the square root of x plus 2 minus 1, we need to start by understanding what our parent curve looks like. Parent curve being the most generic version of this graph we can come up with, so simply the square root of x. Now, the points 0, 0, 1, 1, and 4, 2 are chosen very specifically because those input values are perfect squares, yielding whole number outputs for their y values. If we look at the transformations in our graph, we're going to move left 2, we're going to move down 1. This directly affects that 0, 0 point. We will plot the new point for our new graph at negative 2, negative 1. Now we look at the parent curve for shape. To move from 0, 0 to 1, 1, I move right 1 and up 1. That same shape still applies. I'll move right 1 and up 1 and relocate that point. To move from 0, 0 to 4, 2, I move right 4 and up 2. Same shape. I'll move right 4 from my new center, and I will go up 2 from there. These 3 points allow me to draw myself a smooth curve. To complete the graph, I'll talk about domain and range. My domain is all your input values. If I look at my graph only exists in picture from negative 2 and to the right. That means that h value really controls that lower boundary of my domain in this graph. So my domain will be from negative 2 to positive infinity. When I'm thinking about range, we're thinking vertical. My range, the graph only goes as low as negative 1. Again, looking at that endpoint. And it's entirely above that value. So negative 1 will be the lower boundary. My range is negative 1 to infinity.